Welcome back, everyone, to Digital Dive, episode 11.
Today.
11 already. Wow.
I know, right? It feels like just yesterday we were getting started.
Time flies when you're having fun, huh?
That's for sure. So today,
Yeah, what are we talking about?
we'll buckle up because we are diving into a cosmic mystery.
Ooh, I like mysteries.
That's really turning what we thought we knew about dwarf galaxies upside down.
Ooh, okay. Dwarf galaxies. I'm intrigued.
You and me both.
Lay it on me.
Well, this is all about a little galaxy called Leo P.
Leo P. All right,
But-
I'm listening.
Okay, so for those who haven't met Leo P yet, can you give us a little introduction?
Yeah, sure. So Leo P is a dwarf galaxy,
Right.
which basically just means it's, way smaller than galaxies like our own Milky Way.
Right.
It's hanging out about 5.3 million light years away from us,
Yeah.
out in the constellation Leo.
Okay.
And what makes Leo P really interesting is that it's incredibly pristine.
Yeah.
It's like a time capsule from the early universe.
Yeah.
And it's made up almost entirely of hydrogen and helium.
So no fancy elements.
It's the basic building block.
You got it. Just the OG ingredients of the universe.
So why is that so significant? I mean, why is that such a big deal?
Well, that's like the clue that tells us that Leo P hasn't really interacted much with other galaxies and has remained relatively unchanged for, billions of years.
Wow.
Think of it this way. Most galaxies, they evolve by merging with other galaxies,
Right.
collecting gas and dust, forming new stars, the whole shebang. But Leo P seems to have just skipped all that drama.
Sounds peaceful, actually.
Yeah, for sure.
But, I mean, we're talking about a cosmic mystery here.
Yeah,
So I'm guessing there's more to this story.
you got that right.
Okay, I like where this is going.
So here's the thing. The real head scratcher, the thing that has us all puzzled,
Yeah.
is that Leo P is forming new stars.
Oh, really?
Like brand new baby stars.
That's kind of surprising, right? I thought dwarf galaxies weren't really doing that anymore.
You'd think so, right? I mean, astronomers used to believe that dwarf galaxies like Leo P basically stopped forming stars billions of years ago.
Yeah.
Particularly after this period called the Epoch of Reionization.
Wait, hold on. Epoch of what now?
The Epoch of Reionization.
That sounds intense. Remind me what that is again.
Of course, yeah. So picture this, okay.
Okay.
The early universe, way, way back,
Yeah.
it's filled with this, dense fog of neutral hydrogen gas.
All right, I'm picturing it.
Okay, and then, boom, the first stars are born. And when they, eventually die, they go out with a bang, literally supernovas, these huge explosive deaths.
Right.
And those explosions, they release this incredibly powerful radiation, and that radiation, it ionized the neutral hydrogen.
Oh.
It's like it cleared out the fog.
So that's the epoch of reionization. That's what it refers to.
Exactly. It's like this huge turning point in the evolution of the universe,
Okay, I remember now. So how does Leo P fit into all of this?
Well, the current models, the way we understand it,
Yeah.
they suggest that after this big event, after the epoch of reionization, the leftover gas in these small isolated galaxies like Leo P,
Yeah.
it should have been too spread out, too dispersed for new stars to form. Like the party was over,
Yeah.
But then along comes the James Webb Space Telescope.
Our favorite.
I know, right? The JWST, with its super high-powered instruments.
Right.
It takes a look at Leo P.
And what does it see?
It saw brand new star formation, unmistakable signs of active star birth.
Oh, wow.
Specifically, using its near-infrared camera, the NIR cam.
So this tiny little galaxy that should have been quiet and retired by now.
Yeah.
It's throwing a star-forming party.
It's defying the cosmic playbook, basically. It's showing us that even these ancient dwarf galaxies can, reignite their star-forming engines.
Okay, that's wild. What's going on here? Why is it doing that?
Well, that's the million-dollar question. Leo P's behavior is really suggesting that there's more to the story of dwarf galaxy evolution than we initially thought. Maybe it's a super rare event.
Yeah.
Or maybe our whole understanding of the processes at play is just, incomplete.
So this is why it's such a big deal.
Yeah.
It's not just about Leo P, but what it could mean for our understanding of how all galaxies form.
Precisely. It's thrown a real wrench into our well-oiled models, and now we have to figure out why. Makes you wonder what else we're missing out there, in the vastness of space.
It really does. So how are astronomers trying to, figure all of this out?
Yeah, good question.
What are some of the theories they are considering to explain this unexpected star formation?
Well, there are a few possibilities on the table.
Oh.
One really intriguing idea is that Leo P just like stumbled upon a fresh supply of gas.
Oh, okay. So even out in the vast emptiness of space, a little galaxy could bump into a fuel depot.
Exactly. It's kind of like finding an oasis in the cosmic desert.
Yeah, I like that analogy.
So, this accretion of gas from the intergalactic medium, which is what it's called,
Yeah.
it could provide the raw material that's needed to kickstart star formation.
Okay, so that's one possibility.
Yeah.
What else are they considering? What other theories are out there?
Well, another theory is that maybe Leo P had a close encounter with another galaxy.
Oh.
Like even a relatively small one, you know?
Right, so like a little cosmic nudge from a neighbor could be all it takes.
Exactly. Even these seemingly minor interactions can have a huge impact on a galaxy's evolution.
Wow.
And of course, there's always the possibility that, Leo P is just a total fluke,
Okay.
a rare case.
Like a cosmic unicorn.
Yeah, exactly. A statistical outlier. Maybe, just maybe, some dwarf galaxies can just hold on to that ability to make new stars for much longer than we initially thought.
So it sounds like we have a few suspects, but no clear culprit just yet.
Yeah.
Sounds like more research is definitely needed.
Absolutely. And that's where the James Webb Telescope comes back into play. Because it's not just observing Leo P, it's also studying 4 other isolated dwarf galaxies
Oh, cool.
to see if they're showing any similar signs of unexpected star formation.
So we could be on the verge of like a whole new chapter in our understanding of how these dwarf galaxies evolve.
Yeah.
It could be that Leo P is not an anomaly at all, but like a pioneer showing us this path we didn't even know existed.
It's true. That's what's so amazing about science. Every new finding opens up a whole world of new possibilities, and it leads us to, question what we thought we knew and pushes us to explore further.
It's amazing to think that even the smallest, most seemingly insignificant objects in the universe,
I know, right?
they can hold such profound secrets.
Yeah, it really is humbling.
It's humbling and kind of exciting at the same time.
Totally agree. And what's even more exciting is that we have the tools now, like the James Webb Telescope,
Yeah.
to dive deeper into these mysteries than ever before.
It makes you wonder what other surprises the universe has in store for us.
I can't wait to find out.
Well, I'm sure we'll be back to discuss even more mind-boggling discoveries.
Yeah.
But for now, let's circle back to Leo P for a sec.
Okay.
What are the implications of this discovery for our understanding of larger galaxies, like,
Yeah.
Our own Milky Way?
Yeah, it really is amazing to think that by studying this tiny little galaxy way out there, we could gain insights into the evolution of our own galaxy, our own galactic home.
It's all connected, you see.
Ooh, I like that. It's all connected. So how so?
Well, the prevailing theory is that large galaxies like the Milky Way, they grew through this process of
Yeah.
mergers and acquisitions,
Okay.
combining with smaller galaxies over billions and billions of years.
So by studying these smaller galaxies, we're essentially looking back in time,
That's exactly.
piecing together the history of how these larger galaxies were formed.
Yeah, like a giant cosmic puzzle.
Right.
And if Leo P is actively forming stars, despite its age and isolation, it
Yeah.
really challenges our assumptions about the timelines
Yeah?
and the processes involved in galactic evolution. So it's not just a curious case.
No.
It could potentially, reshape our whole understanding of the Milky Way's own history.
That's right.
That's huge.
For instance, if this accretion of gas from the intergalactic medium, remember,
Yeah.
if that's happening more often than we thought.
Right, then galaxies have more fuel to make new stars than we thought.
Exactly. And that could totally change our predictions about how long galaxies can actually keep making new stars.
And that also probably impacts our understanding of, how the chemical composition of galaxies changes over time.
You're getting it. You see, all those heavier elements we find in the universe,
Yeah.
like the carbon and oxygen that make up, us.
Yeah.
They were all forged in the hearts of stars.
So if galaxies can keep forming stars for longer,
Right.
it means they're also producing more of those elements.
That's the idea. And that has implications for everything,
Wow.
from the formation of planets to the emergence of life itself.
This is blowing my mind right now. I mean, it's incredible how this one small galaxy is opening up so many new avenues of research and exploration.
It really highlights just how interconnected the universe is.
It really is.
Every discovery, no matter how small, can have these huge ripple effects and change our whole perspective on the bigger picture.
Well, this has been a fascinating deep dive
Yeah.
into the world of dwarf galaxies and all the mysteries they hold. And it seems like every answer we get just leads to even more questions,
It always does.
which is pretty exciting.
That's the beauty of science, right? The quest for knowledge never really ends.
Well, I'm already looking forward to our next cosmic adventure.
Me too.
Thanks for sharing your expertise with us today.
My pleasure. Keep looking up and stay curious.
And to all of our listeners out there, thank you for joining us on Digital Dive. Until next time, keep exploring the wonders of the universe.